Hello, my name is Josh Obrecht, and I am a GIS analyst with the ACPF National Hub. Unfortunately, the records for which fields have tile drainage installed are not always available or even exist. In this video, we're going to discuss the tile drainage classification tool. This is the second tool in the field characterization section of the ACPF Toolbox, and this tool identifies fields that are likely to be tile drained based on soil and slope conditions. In ArcGIS Pro, we will open the catalog window in the right side of the screen if it isn't already by clicking on the catalog tab. Expand our ACPF toolbox and expand field characterization. Double-click the tile drainage classification tool to open. This tool has multiple inputs, including the field boundary feature class, the GCirgo raster, which contains our soil information. We also have a couple of conditions and a logic statement, which will tell us whether we want the relationship between the two conditions to be more restrictive using AND, or more inclusive using OR. We'll keep this tool open for future use. Let's take a closer look at the conditions that can be chosen for this tool. The first one deals with slope and states that at least 90% of the field is less than 5% slope. This value is going to be required and cannot be changed. The second condition deals with the soils. The user has to select one of four options. The first option is that the field has a mean hydric soil percentage of at least 10%. The second option is that soils of a dual drainage class or D-class soil occupy at least 40% of the field based on the user's knowledge of the watershed and how the soil survey was conducted. This second option also allows the user to exclude those classes that are only D-class. The third option is that at least 40% of the field has a seasonal high water table defined as less than 50 centimeters in April, May, and June. The last option are fields with at least 40% of the field designated as a poorly drained soil. These are soils defined as somewhat poorly drained, or very poorly drained. Finally, the user has to make a choice of using an AND statement, which is more restrictive, or the OR statement, which is more inclusive. When using the AND operator, both the slope and the soil condition has to be met for that field to be classified as tile drained. When using the OR operator, either or both of the conditions can be met for it to be classified as tile drained. Comparing the soils options, there are some differences between the potential results. In this example, the western half of the watershed shows some differences between soils options. The soils that would be included for this watershed for each option are in blue. The areas in brown would not be included. Back in ArcGIS Pro, we will enter our inputs into the tool. For the first input, we'll choose our field boundary feature class. An important thing to note here is that these tools won't run if there is a join on a feature class being used. If you have previous joins on the field boundaries, you will need to remove them. When we choose our field boundary feature class, the second and third inputs will automatically populate with our GCirgo raster and our slope table. Next, we have our conditions and logic gate. The first condition is never going to change. It's always going to be at least 90% of the field has less than 5% slope. Then we have our logic gate. We will choose OR so that we are including more soils. And then condition 2 for the soils, we will choose the dual drainage and D classes. That's option 2. We will keep the exclude D class soils unchecked so that they will be included. You will use your local knowledge and other resources to make these decisions. Our output has automatically populated going to our geodatabase, so we will click Run to run the tool. The tile drainage tool has just finished running, and we can see that the result, a drainage table, has been added to our map. If we right-click on it and choose Open, the attribute table opens. The table contains the field boundary ID number, which as previously stated, will be useful when we want to join the table to the field boundary feature class. The next few columns deal with the soil and slope conditions that were the tool input options. We start with the mean percent hydric soil. Based on GSurgo, we calculate the area weighted mean of the hydric percentage of each map unit within a field to calculate this percent hydric field. Next, we have the percentage of the field that is dual drainage class soil, calculated as the percent of a field that consists of either dual drained class soils, that's AD, BD, CD, or just D class soils. The percentage of the field that has a seasonal high water table, and the percentage of field that has poorly drained soils are the next two fields. The last of these fields is the percentage of field that is less than 5% slope. We also have our IsAg field, which tells us if a field is cropped, pasture, or non-agricultural, and our drained field. Based on the query that we used when we ran the tool, we get an output of whether the field is likely or unlikely to be tile drained, or if it's not agricultural. The drainage index value is an integer value, initially set to 0. Each field is given 1 point for each of the 4 soils conditions that are met for a potential value of 0 through 4. An additional 10 points is given if the slope condition is met, resulting in final potential index values of 0, 1, 2, 3, 4, 10, 11, 12, 13, or 14. A field that meets all soils and slope conditions will receive a value of 14. You may be satisfied on the results of this tool. However, if you have local knowledge as to whether a field is drained or not, and it doesn't happen to match these results, or you would like to generate another query using this data, you can change these results right here in the table. You can change them manually, or if you right-click on the field header and choose Calculate Field, you can create a new query in the code block area and get a new output for your drain field. This is just a little bit of info if you'd like to explore further into this information. However, it's not necessary. So let's visualize this tile drainage table. To perform the join, right-click on the field boundary feature class and go to Joins and Relates and click Add Join. This will open the Add Join window. Our field boundary feature class will auto-populate as the input table, since that is the one we will add the join on. The drainage table auto-populates as the join table because it is the only table that we currently have in our map. If there were other tables in the map, you would need to select the drainage table from the dropdown. For input field, we will choose our field boundary ID. Since the drainage table has the same field, ArcGIS Pro recognizes that the field exists and will set that as the join field. Let's hit OK at the bottom of the Add Join window. Select our field boundaries in the table of contents on the left and click on the Symbology tab in the right panel to open the Symbology window. From the dropdown under Primary Symbology, click Unique Values. We will be visualizing on the drain field, so we will select that field from the field dropdown. For color scheme, we will select Set to 3 classes. Make sure that Show Name and Show All are selected. Now we get an idea of which fields are likely to be tile drained, shown in blue, and which ones are not as likely, shown in the green color. This is helpful for visualization, but don't forget to actually look deeper into your table to see why the fields are not likely to be tile drained. Let's open the attribute table of our field boundaries by right-clicking on the field boundaries in the table of contents and clicking Attribute Table. Right-click on the drained field header and click Sort Ascending. The table is now sorted to show the non-tile drained fields first. In this example, we ran the tool on slope or the dual drainage class condition. Looking at the first couple records of the not likely to be drained in our table, we have percent slopes that are well below our 90%. We also have our dual drainage that is less than 10%, and our value that we were looking for is 40%. To recap, we ran the tile drainage classification tool and discussed what values are provided in the drainage table. In the next video, we will run the third field characterization tool, D8 distance to stream.